lastly, we shall look at, of course, we have mentioned about the mechanisms, reaction mechanisms. So these are some of the aspects which we are going to look at under chemical kinetics as we go by. So for that case, as we have mentioned that one, and we have given it a definition for that, we can just look at it in just a nutshell and try to see what is reaction rates. So in this case, how do we determine, as we have said, that the rate is change of a particular, or change of something over unit time, and the reaction, as we know, is that it's the change maybe of a interaction of chemicals when they come together and to form products. So in that particular aspect, then we can ask ourselves, as we were saying that the reaction rate is measure of a concentration over time, then what concentration are we measuring? So in this case, as we said, when we gave a general formula for a reaction and said that A is reacting with B to form C, product C and D, then we have a specific notations that we are going to use for concentrations of different substances, maybe of the products and the reactants. So in this case, there's a notation for this specific concentration. If we are referring to the concentration of A, then we're going to give it as the square brackets of A. So in that respect, if we are referring to the concentration of B, then it's going to be given as the square brackets of B. So the same goes for the products, that's the concentration of C and D respectively, are going to be given in that order. Now for instance, we have maybe a reactant that is forming a product, maybe A forming product B, then we shall indicate the concentration of A as the square brackets of A. This is a reactant. And the square brackets of B is a product. So this one implies the concentration of reactants and products in particular. So how do we measure the concentration of the reactant and the product in that case? Of course, there are two ways of achieving this. So we can measure the rate at which the reactants, of course we said that if this reactants is going to be consumed fully in order to form a product, at the end of the reaction we find that the concentration of A, or the amount of A, is 0, whereas the amount of B is at a whole percentage. Of course we can just literally use that the concentration, or maybe the percentage of A at the end of the reaction will be 0%, and then the percentage of B at the end of the reaction, which is a product, will be 100%. So this one has been fully consumed to form that product. So for us to measure this one, for the reactant to form a product, it will take a specific